And thank you all for being here. So yeah, I get to talk today about a confluence of a couple trends, foundation models and a push toward more data-centric AI and how they're interacting today, which is pretty exciting. Actually, I'm going to need the clicker, I realize. Here we are. This should work. There we go. OK, we'll start with this clearly very scientific graph showing approximate progress, I guess, in AI, where clearly we've just seen an inflection point in recent years, right? With the advent of deep learning maybe 10 or so years ago now, and then foundation models in recent years, realizing we can pre-train these models and get a lot of performance out of the box. It's resulted in a lot of applications where it feels like suddenly it's actually pretty realistic to deploy AI where we couldn't before. And especially in, I think, the past few months, it's caught the public eye that you can make some pretty mind-blowing demonstrations in particular with just out-of-the-box zero-shot behavior, which is super exciting. Well, sorry, I guess to hit the subline there, as a result of this, we've got everybody's talking, right? Literally, my 60-year-old aunt asked me, what's a large language model? And I never thought I'd ever get that question. It was fun to explain. But it means that not just consumers, but every company is trying to make sure, how do I not miss this trend? How do we get a part of this goodness, this clear sort of revolution of sorts in what AI can do? But there's a gap that they're all noticing, and this is probably what makes it so frustrating for them, is that I see these incredible demos. They say it took them 15 minutes to do. We've been working on this AI project for 6 months, and it's not out the door yet. And why is that? Where is this gap, and what makes this so difficult to actually get enterprise return on investment in these AI projects? And we've identified from our own experience and following this field very closely for the past 7+ years, since the Snorkel project began as a research initiative actually at Stanford, recognizing there's a couple of gaps that are the ultimate culprits for why there's a bottleneck to getting this type of technology, these foundation models, and all the goodness that they bring into production and returning value. One of these being the need to adapt these models, that when you move beyond pretty cool demo to actually high accuracy, ready for production use cases, you need to fine-tune these models and make them have the ability basically to teach them that last mile to be good for your task. And then deployment, the fact that these models are extremely cool and powerful, they're also very large and unwieldy, and in many cases totally impractical to deploy directly. So companies want to know, how can I take advantage of this clearly useful technology while finding a way that practically will let me use it even if I can't deploy it directly? So I keep using this phrase data-centric AI, and that's part of what we see as the solution to getting past both of these problems. What is data-centric development? And this is best understood in the context of how have things historically been done. And there was a period of time which we sometimes internally refer to as the Kaggle years, where most machine learning projects started by downloading the data set or collecting a single data set up front, assuming that that's fixed, and then mostly iterating on the model, seeing if you could hyperparameter tune your way into a better local optimum, or see if you can add just one more attention head in the right place. Will that make the difference? But in reality, I think as time's gone on, people have realized models at the end of the day are essentially sponges. They soak up what's in your data, and if your data doesn't have the information that your model needs to know to do the problem well, you've got very little hope of it succeeding. So increasingly, we've seen iteration shift back to the data, and the realization that that's where you need control. That's where you need transparency and auditability and the ability to have some high leverage ways of modifying the behavior of your model via the data. So you'll take a look at the models today, and in many cases, we're using the same model for the past 5 years. If someone found a pretty good model, transformers, works pretty well across a lot of domains and a lot of applications. Same thing actually on the hardware. Once upon a time, that was a bigger piece of getting an ML project off the ground, and now anybody can have a GPU pretty quickly from any one of a number of different cloud providers or on-prem or other things. But really, the data is what becomes the differentiator and the bottleneck for getting out a new project. So I alluded to this a little bit before, but this is not a new area of interest to us. This was about 7 years ago, the Snorkel project at Stanford, where we recognized this trend. We saw TensorFlow and PyTorch had come out. The cloud compute providers were spinning up. It was like, okay, these are going to become the commodities. It's really the data where you need higher amount of control and access. And so that's where we've been focusing for a number of years, first as researchers, and then for the past few years as Snorkel AI, the company. So let's talk a little more in depth about these two challenges that I mentioned. The first being that adaptation piece. And the way to think about this is sort of no matter how strong a person's background is, you're not going to expect them to like nail the job that you care about exactly the way that you would do it on their first day on the job, right? There's going to be some training. I think about like if you're at a legal firm, it's great that now today you can start with somebody who has the equivalent of a college degree rather than an eighth grade education. That's what foundation models can do for you. It's very exciting. They're that much better at reading and writing and understanding things. But they're still not ready to go and handle that high-value customer account that you're dealing with. Even if they have a law degree, still, like, there's going to be nuances to your customers, your accounts, your data, the way that your firm likes to approach different problems. And that means that there's this last mile, or I'd say typically something like 20% of quality and performance that needs to come from your task, your data, your priorities, that specific piece that you're going to use to fine-tune the model. So, again, taking this back maybe to more of a graphical standpoint, you can think of a couple of axes. There's other ways to think about it, but here's one, where on the bottom we're looking at basically what are my quality requirements? How good does my model need to be? And if I'm just riffing with the model, having a fun time making poetry in the style of whoever your favorite artist is, that's not an area where you need super high quality. It can take me 15 tries to get something good before I share that on Twitter. Not a big deal. But if you look at some use case like actually the one we just heard, right, from Shipped or others, where no, I can't have a 1 out of 15 success rate. Like I need this to be extremely reliable. My company's reputation is going to be on the line. I'm not going to be able to monitor every single output. And so that's a place where adaptation is required because you want to have that control to improve the quality of the model. On the other axis, you can look at your domain complexity. So the way foundation models are trained, the way we've found a way to get significant portions of the knowledge on the internet into a model is by having them basically do these types of tasks where we can create essentially unlimited amounts of data, predict the masked word, which is great. But it means that their experience is primarily with that one task and primarily with web data, which is not necessarily your domain, not necessarily your specific neck of the woods in terms of a concrete medical task or financial task or underwriting task or whatever it is that your task is. So there again, we see that it's pretty cool how much they can do out of the box. They do have a little bit of knowledge about a lot of topics, but it's sort of a jack of all trades situation where they need to be taking that last mile, that last 20% to understand the specifics of your problem and domain. So again, that's a reason why this adaptation becomes necessary. And the second challenge then on this deployment side is even if a model is sufficient, out of the box to do pretty well on your task, maybe your quality requirements are low and your domain's not that unique relative to what they were trained on, there still is the fact that these models are monsters. They're often multi-GPU setup. You need often a specific skill set just to even load and run the model without getting out of memory errors or have it work in a sane way. And so one option is to host it yourself, and there's certain costs associated with that and investments. And it's not just for the hardware, but also for the know-how and the commitment to ongoing, have your own little, operation, I guess, in a new area that may not be a significant part of your, differentiation as a company. The alternative is to ask, somebody else to host this model for you, if you're willing to pay for it on every ping, every prediction. But then this exposes you to other sorts of risks because now a important piece of your IP and things that you care about is routed through some other company, and there's uptime issues or latency, or just for many folks it's a non-starter. We're not going to send our data to another company, and even if we are, we don't want them to hold the model. We need to be able to inspect that and update it and make changes to it ourselves. So there's a bit of a catch-22 when folks figure, well, if I need to deploy this model, how am I going to do it? And there's not really a great option much of the time. And the sad thing is that it's not actually even necessary for you to have the whole model. If you look at what these models know, it's a lot, and some of that is relevant to your domain, but they also can do a pretty decent job of providing trivia about George Washington and pickleball and puppies and everything else. And if you try and deploy the whole model directly, then on every inference call, you're paying for all that extra capacity spent on things that don't actually matter to your problem. So a far better idea is to acknowledge these have relevant information for my problem, but is there a way for me to suck that knowledge out, the relevant pieces, and get that into a much smaller form factor that's appropriate for my business and for my application? And then the last, I guess, piece to consider here is just, I think there's a whole world of hurt coming for companies that want to go, that data scientist who's super excited about this model and thinks they can deploy it, but you got to get past model risk management teams. And I think some teams who don't have model risk management teams are going to deploy and then find themselves being sued for unexpected behavior of models. There's just a lot still being figured out. How we control what these do. Actually, we saw what was it 9% of Google's market cap cut away in a day because of a unexpected answer from their model that they posted. And so there's just the difficulties of trying to deploy directly a black box system without a little more control. So both these issues, I want to make sure you don't walk away thinking, Braden thinks foundation models don't have a place here. They're incredible. They've got a lot of potential. But you do need a concrete way to get past both of these issues. And the way we see that can be done is via a very data-centric approach. The fact that you can transfer knowledge via data sets. You can control knowledge by controlling what's in a data set. And that gives you a lot more power than trying to directly reason about or deal with this large 100 billion parameter model that's very difficult to manipulate directly. There we go. So the focus of today is not necessarily on our platform Snorkel Flow, so I won't go deep, but just to give you a sense of the high-level overview, it's a platform for essentially building and refining training sets and training models and then iterating very quickly there, often in one setting based on what you see. So you'll label data programmatically. Rather than labeling individual examples one by one, you can use foundation models. You can use heuristics. You can use other resources that you have to, as programs, label data and then train a model on that, see how it's performing, and then based on error modes that it has, update your data directly with a new labeling function or modifying a labeling function that you have. And then that lets you basically, again, as I said, like in a sitting, update hundreds of thousands or millions of data points and get to a model that's going to perform well for you. And actually, per the point that was made previously, there's a need often to update your models to monitor their performance and then change their behavior. And a nice thing about labeling programmatically is you can tweak one of your labeling functions, push the re-execute button, and relabel all of your data at once, rather than having to say, all right, it's time to relabel our data again, spin up the workforce of crowd workers to label. That doesn't scale well from a cost perspective. And then also, I guess, just the audibility that you get from having individual programs you can inspect. But again, I'll leave this a little bit for another time. Happy to talk to anybody at our booth about the details of how this works. But from a foundation model standpoint and where this fits, you think of this basically as, at the end of the day, my goal is to have a specialist model. And that model, if it needs to be, could be a foundation model. If I think that I just truly need that much capacity, or I need specifically what's in that model, you can use Snorkel to develop your training set, fine-tune it, and deploy it. Often what we find folks want is a smaller model that's already pre-approved or easier to approve by their model risk management team, and that it does not carry necessarily any more mass than it needs to, beyond what's sufficient for your problem. So you'll use a general purpose foundation model as input via these features I'll mention on the next slide, warm start and prompt builder, basically ways of converting it into a labeling function that now is commenting specifically on just what matters to your problem, using that to create the training set that you fine-tune a model with, and then continuing on with this iteration loop. So these three features, the first being fine-tuning, that's just what I mentioned. The fact that models of many sizes, I think of the BERT family as maybe the smallest of the foundation models that were pre-trained on large tasks, but can be much smaller. Once upon a time, BERT felt huge, but now is quite small in comparison to the GPT-3s of the world. But the idea being that once you've made a task-specific training set, you can fine-tune a model and deploy that. Warm Start says basically uses your starting point for labels, whatever the foundation model would do. So they often do quite impressively, much better than random. They've got good initial suggestions. It's just not going to be perfectly aligned with what you want, but use that as a starting point. So your initial labels can come from what does GPT-3 think the label should be. And then the prompt builder is basically a way to write additional labeling functions by prompting these models to correct, to say, hey, here's a situation where out of the box it's mislabeling. Can I correct that by guiding it to specific types of examples? So to make this concrete, for example, actually I think I'll do that in just a second. Oh, maybe not. Okay. To give an example, I'm maybe making a spam classifier. My initial labels will be, is this email spam or not, and get those initial predictions. With the prompt builder, I could then add more detailed things like, is this email asking me for money? And if so, label it as spam. Like that's a place where I can inject a little domain knowledge that I have about the problem that maybe GPT-3 didn't realize was a category of spam. So there's ways to update its understanding of the problem. So I'll give an example of this real quick before I wrap up, where we actually went and applied this to a problem. There's a a data set, and it's a legal data set, so this is not necessarily common knowledge. Many of us would not do a good job on this task, but it's a 100-way classification problem where for a bunch of legal contracts, can you classify the purpose of each provision, each paragraph essentially. There is a whole blog on this. If you look for better, not bigger on our snorkel.ai/blog, you can see more details and a bunch of ablations. But basically, we wanted to see how we could do on this with foundation models. And specifically, the approach we took was this idea of distilling their knowledge into a smaller form factor. So we used 4 different foundation models, varying in size, from GPT-3, an open source one called FLAN that came from Google, Coherent AI-21, that's 2 closed source models from other companies. And each one of them has different areas where they're better or worse. They were all trained in slightly different ways. None of them were quite good enough out of the box to do well in our problem, but we tossed them all in, made each of them a labeling function that suggested a label for our data points, and combined those to get kind of a single label per example. And then with the training set that we've made, we actually fine-tuned a much smaller model, Roberta, which is 0.1 billion parameters rather than 100 billion parameters. And I'll go through a couple results slides here. The first being, just taking a look at the GPT-3 lines, you can see 0 shot out of the box actually did pretty poorly, a 29.9 accuracy. Giving it a few examples, a small amount of data to kind of just help it figure out what it knew that was relevant to the problem, it did improve significantly. But as is almost always the case, the very best results that we got, and if we wanted to drive this further, we'd do further iteration on this training set, but you get the best results by fine-tuning that model on a task-specific training set that you've been developing. And in this case, you get 40 plus points by spending a little bit of time not just accepting it out of the box, but letting you actually teach it a bit more about your task. The other interesting thing was once we've made this training set from these models, they were the primary source of knowledge here. So I wasn't even injecting any of my specific domain knowledge. I was just saying, let's just pull out the relevant pieces of what they know about this problem and combine them. And then when I train a different model, Roberta is about 1,400 times smaller than GPT-3, but it achieves essentially the exact same accuracy, right? Within the margin of error, certainly. So what we see here is I don't actually have a problem that's so complex it needs 100 plus billion parameters. That's just the model that had the information I need. What I really want to do is suck the relevant knowledge out and then put it in a deployable model like Roberta, which can run on a single GPU, which I can run myself, which is is actually dramatically cheaper to run. So the result here we saw was identical accuracy, but literally 1,000 times cheaper to run in production. And it's benefiting from foundation models, but it's getting past that barrier of A, adapting them by now fine-tuning them to my task, and then B, deploying them by sticking that knowledge in a much smaller form factor. So this is, what I'm showing here is a bit of a technical overview, right, and a single case study. It was important to us to make all of this not just kind of the domain of ML PhDs, but make this accessible. That's where the platform we built, Snorkel Flow, comes in. And this slide's just to say this isn't just a lab experiment. This is something that now we're doing with lots of different companies across a variety of different domains, and it really spreads, covers across many different industries, because at the end of the day, they're machine learning problems. This is a supervision problem. It's not about having a specific solution for ag tech or fintech. It's about how do I get knowledge from pre-trained models into the right form. So happy to speak to any of these again at our booth afterward. For more information, feel free to ask a question now. Also, the timing works out just right that actually tomorrow we're doing a demonstration of our foundation model suite in a webinar, and that's free. So if the Snorkel.ai events, you could sign up for that. We also have a video recording, so if that conflicts with other things, we can send that afterward. And then we've got various additional things on our blog or follow-up meetings. So with that, I'm happy to take some questions for a few minutes.